All right, so this little piece of gear here is going to be our electrical stimulator. It does lots of other things. We're going to be using it to measure your electrocardiogram and spirometry, but for today we're going to use it purely as a way to generate electrical signals that we can use to stimulate the body. The electrical signal comes out these little wires. It's totally electrically isolated from the power main, so there's no way you can accidentally electrocute your subject, so it's totally safe. To control it, we're going to use a program which we run on this computer. It's called Chart. I'm opening up our little biology, physiology folder, the settings subfolder, and where it says nerve stimulation, this has the settings for this particular nerve stimulation lab. And there's very simple settings that we have set up for y'all. You're not going to change pulse width. Pulse width is going to always be here at 0.2 milliseconds. It just means when you send out a stimulus, it's a short little pulse. The things that we are going to vary is the current, the electrical current measured in milliamps that is being delivered across the electrodes. And we are also going to be altering the frequency, the repeat rate, like how many times per second are the pulses coming out of the electrodes. And I can demonstrate that in a visual way. We're going to actually be stimulating your sensory nerves as part of the lab. But right now I actually have the electrode up against my median nerve here, so it's going to actually stimulate a motor nerve, which will be causing my thumb to move. And I can go here. I'm going to set the current up, 20 milliamps, which is going to be enough to notice. And if you can show my hand here, if I say send out a pulse, you can see my thumb go. So I'm going to turn on the pulse. Here we go, pulse, my thumb went. Right now the repeat rate is at 0.1, which actually means like one pulse every 10 seconds. So if it's set here, if you just turn it on, you'll have a pulse. As long as you turn it off before 10 seconds is off, that'll be the same as doing a single pulse. There is no way to just tell us to do one single pulse, but it's the same difference if we say 0.1 hertz and then make sure we turn it off before 10 seconds have passed. Now what I'm going to do is I'm going to change the frequency to 1 hertz. And you'll see it's sending out 1 pulse every second. So this is important to realize. 1 hertz is very different from a single pulse. 1 hertz means there's 1 pulse coming out every second as long as the stimulus is on. A single pulse would be there's a pulse and then nothing. I can increase it. I'm going to go to 2 hertz, which is 2 cycles per second. And now all of a sudden my finger's going twice as fast. I'm going to go right now and change it to 5. I can go even more. I can take it to 10. At this point I'm starting to get into tetanus. It's actually getting kind of uncomfortable, so I'm going to slow it down and turn it off. Ah! So that gives you a sense. This is, again, motor, which is not what we're doing, but to give you a sense of what frequency means. When you are on, you have the stimulus repeating. It's coming out a certain number of times per second. We'll also be using this just to deliver a single pulse and then turn it off. So that's that.
Okay, so for the nerve stimulation lab, we're investigating 2 different things. So we have 2 independent variables. One of them is going to be the location on the body where we're actually putting the electrodes. So one place we're testing is the fingertip. And then you're going to move the electrode and go through exactly the same procedures into the calf. And so you're going to get a whole set of numbers here. That you will report for finger sensitivity when they felt a little electrical stimulation versus when did the calf get it. And so all these numbers that you're going to report are going to be in milliamps. And so the other independent variable, in other words, the thing that you're varying in this experiment, is also the frequency. So you see here I have a single stimulus, and then we tried multiple stimulus, and we're going to try 1 hertz, 5 hertz, 10 hertz, and 25 hertz. And so what we're recording, we don't care about any numbers that you don't feel. So you don't have to record anything in the lab book that you don't feel. But as soon as the subject feels like the little tingle, that's the number that you want to record. And so, of course, we don't want to start off too high. So we want to, so the person or the subject feels it right away. So we're going to start at a lower number. And so hopefully the subject doesn't see it, and then feel it, and then we're going to increase with 0.2 milliamps, and you're going to keep doing that until they say, oh, I feel that. And when they feel that, that's what you're going to record. And so I've done this experiment once upon a time myself, and so I'm just going to kind of illustrate with numbers what the process is going to be. So for a single stimulus on the fingertip, we would probably start at 1.0 milliamps, and in that time I didn't feel it, so we raised it to 1.2, and I didn't feel that either. We raised it another 0.2, so now we're at 1.4, didn't feel that. I got to 1.6, and now I felt it. So that would be the number that I would record in my notebook for finger, 1.6 milliamps. All right, so now we're ready to start the multiple stimulus kind of experiment. And so what you want to do to start off now, where the subject won't feel this, is to subtract 0.6 from whatever they felt here. So if I subtract 0.6, that means that I would start this one with 1.0. But the subject probably won't feel that. And so then you're going to erase it with 0.2. And so the next one you're going to try is 1.2. And let's see. And then in my case, I didn't feel that either. So I raised it to 1.4, and then I felt it. And so that would be the number I would record in my notebook, is 1.4 milliamps. All right, so next you're going to move on, and you're going to increase the frequency. And so we're going to do this again, where you subtract 0.6 from this. And so in that case, you're going to start at 0.8. And so you're going to go up with 0.2 and so forth until the person feels it. And so you would get a set of numbers. And so I'm just going to finish this chart here with the numbers I got, but everyone is different. Some people are more sensitive than others. So of course, this is just what happened when I tried this. All right, so once you're done with this, you're going to do exactly the same experiment again, but you're moving the electrode to the calf. And so you just follow those procedures, you record those numbers in your lab notebook. But we want to take a look at these numbers here and actually see what's going on. You might notice that as we're increasing the frequency, what we're doing is we're sending more impulses through that wire per second. And so as David showed earlier, you saw his thumb, showing how often those impulses are. So you notice that the time that the subject actually felt the stimulus, it tends to decrease the milliamps here. So it gets more and more sensitive. And so the reason for that is because we're doing something called temporal summation. As you might remember from lecture, that you can have these graded or receptor potentials from these sensory neurons. They can go up, but they don't reach thresholds, so no impulse is sent to your brain feeling this little tingle. And so if you have a graded or receptor potential here, and then it has long enough time until the next stimulus happen, no action potential will be generated by the sensory neuron. However, if we increase the frequency, you're sending those impulses closer together. And so what's happening is we get one going here and starting to go down, but we zapped it again. And so what happens are that these graded potentials will now start to stack. And if they reach threshold, we send off an action potential, and the subject will feel or perceive that they're feeling this tingle. So when a subject is feeling or reporting, I feel that, that's called perceptual threshold. It's the minimum threshold where you can actually sense something. And so the reason in this case that we're varying the frequency is to get this stacking of these graded potentials because they're closer in time.